And we should be live. Greetings everyone. Thank you for joining yet another Digit AMA. We'll be talking about the AMD Radeon RX 6000 series of graphics cards in this particular AMA, which is based on AMD's latest RDNA 2 microarchitecture. This AMA is sponsored by AMD, and all the materials that we are showcasing in front of you, including all the presentation as well as the performance metrics, have been shared by AMD. If you wish to get more information, then we have reviewed all of these graphics cards, all three, including the 6800, 6800 XT and the 6900 XT, on our website in the review section. So you can head over there and check it out if you wish to. With that out of the way, we'd like to begin our session with a brief presentation when we'll be looking at the key features of RDNA 2, and then we'll be looking at performance metrics of all the three graphics cards, including ray tracing. And another announcement that we'd like to make is that we are monitoring the chat and we're looking for the 10 best questions, and those will be getting Amazon vouchers. We should see a little announcement in the chat section happening as well. So please pay attention and try to get as many questions as possible our way, and we'll try our best to answer them. With that, we will switch to the presentation. Just a second. There you go. And we'll begin. So when it comes to gaming, there are two key performance contributors: the CPU and the GPU. They work hand in glove, and AMD recently launched the Ryzen 5000 series of CPUs on the 5th of November, followed by the Radeon RX 6000 GPUs in late November and early December. We've already conducted an AMA on the Zen 3 processors earlier this month, which you can check out on our YouTube channel. And coming back to the topic, we have two fresh launches from AMD in the CPU and GPU space, and both have come out with considerable gains in performance. So this particular AMA is all about GPUs, which we are going to look at now. So RDNA is AMD's latest GPU architecture that was unveiled with the Radeon RX 5000 series of GPUs that were launched last year. Before RDNA, we saw the GCN microarchitecture, and those GPUs primarily ended up being in the mid-range and entry-level segment. With RDNA, AMD overhauled its approach towards raster graphics, which resulted in the RX 5000 series being really good in mid-range and entry-level segments. And now with RDNA 2, AMD has improved upon the power efficiency as well as frequencies, so you get even more performance. So not only with the video buffer bandwidth, you also have improved performance thanks to AMD's Infinity Cache. And another key feature addition is the support for DirectX 12 Ultimate, along with the support for Direct Storage API. Now these things require game developers to incorporate them into video games, so we should see more of those games incorporating these new features in the coming months. The latter is also a feature that's present on consoles. The RDNA 2 GPUs are all designed on the same 7nm process that RDNA 1 was designed with. Over time, AMD has streamlined the microarchitecture to improve upon the power efficiency and also the clock frequency. On the right, we have a graph which charts the frequency of the GPU against the power levels consumed per compute unit. Now, the compute unit is a logical segmentation of the GPU, and different GPUs that are present in the 6000 series, or any for that matter, have different levels of, or rather different amounts of compute units. Now these compute units handle the entire graphics pipeline of the GPU. So RDNA 2 has achieved up to 1.3 times the frequency that RDNA 1 was capable of at the same power level. And now if you were to, let's say, keep the frequency constant and look at the power levels, then you'd see that RDNA 2 consumes less than 50% power of RDNA 1, which means that these new GPUs are more scalable in terms of performance thanks to the improvements made with RDNA 2. Now, one of the major changes with RDNA 2 was with the cache hierarchy. Now, cache is where you sort of store all your game data files, sort of the visual files. And with the with the RX 5000 series, there was a private L1 cache linked to a 4 megabyte L2 cache. Now, this again was tied to a 256-bit interface on the die, and together they gave a bandwidth of 448 Gbps. With RDNA 2, there was a requirement for more performance, and that meant more bandwidth was required. One way is to use a wider interface. So a wider 512-bit interface on the die would have solved that problem. But the thing is, a wider interface also consumes a lot more power. So AMD came up with something called as the Infinity Cache technology. Now, Infinity Cache is basically a 128 megabyte L3 cache that is on die, and it's very much linked to the Infinity Fabric technology that's present in multiple AMD products such as Ryzen processors, and even on the server side you have the EPYC processors. The Infinity Cache works with the Infinity Fabric to allow for much more bandwidth. This is one of the key requirements to push performance, especially in high resolution gaming. Now, let's take a look at the impact of Infinity Cache. Straight up, we see an improvement in bandwidth at low power in the very first graph, and then you get better frequencies because now you have more bandwidth to feed the GPU and also crunch out all those frames. And because the cache is huge and fast, you have a lot more data stored closer to the GPU. So the GPU doesn't have to spend a lot more time reaching out down the cache hierarchy and figuring out where the data is that it requires. It's much closer, so there's low latency. So these three things together help a lot with the performance impact. Then we look at certain advanced features that RDNA 2 incorporates. These include several new features and also APIs that are more open. Now, these were introduced with DirectX 12 Ultimate. We have DirectX Ray Tracing or DXR, variable rate shading, mesh shaders, and sampler feedback. Video game developers again have to factor in these features during the development process in order to take advantage of them. And we've already seen quite a lot of games make use of DirectX Ray Tracing in this quarter alone, including the recently launched Cyberpunk 2077. Speaking of ray tracing, let's take a closer look at the ray tracing implementation. Now, with RDNA 2 graphics cards, we've already mentioned that these things are based on, or rather not based, put together using logical segmentations called compute units. Now, each compute unit within the GPU has something called a ray accelerator. Now, this is a dedicated piece of hardware for accelerating ray tracing within video games and also content creation applications. And because the ray accelerator is present in each compute unit, the design becomes scalable. So if you add more compute units within a GPU, let's say you're moving on from the 6800 to the 6800 XT to the 6900 XT, you get more performance in ray tracing. And now we'll be looking at the different impact of, let's say, putting all these features together, including all the performance improvements that have been made over the time. To summarize, we've seen higher performance at the same frequencies. Then we've seen that the frequency can be raised to higher levels, and it takes good God, there's someone calling. And all of these put together result in high performance per watt gains as well. On this slide, we can see the performance per watt improvements across the last two generations. From GCN to RDNA 1, there was a 50% bump in performance, and from RDNA 1 to RDNA 2, there was an additional 54% performance increment. On the right hand side, we can see the breakdown of what all factors have contributed to this particular increase. There's design frequency, which was contributing to about 16%. Then there's power optimizations, which again contribute to around 17%. And lastly, the performance per clock increment, that gives a boost of roughly 21%. So all of these are like pretty mighty contributors to performance. And now we come to the three RX 6000 graphics cards that were released recently. These are all high-end cards, and they're designed for 4K gaming. The RX 6800 is what you'd get if you're currently on, let's say, 1080p gaming or 1440p gaming setup and wish to move up to 4K. Then comes the RX 6800 XT, which offers 4K gamings with more settings set on high or ultra. And lastly, you have the RX 6900 XT, which is the absolute top end card for which you, let's say, you can experience 4K gaming with all the bells and whistles. And this includes ray tracing as well. Now, ray tracing has been around for several decades, but it's only recently that hardware accelerated ray tracing has made its way into video games. Now, traditional rasterized graphics can emulate lighting and reflections quite well, and it's quite impressive. We could even say that it's difficult to tell the two apart if it's really well done. Ray tracing, on the other hand, produces a more natural and lifelike reflections in video games, which is why they also tend to be really compute intensive. And that again is the reason why we didn't see it in graphics cards up until recently. Now, with dedicated hardware accelerators or other ray accelerators within the GPU, you now have something that can dedicatedly work on ray tracing and therefore get a little more performance. Now, the Radeon RX 6000 series of graphics cards uses DXR, that is Microsoft's implementation of ray tracing. And here we see the performance in several video games. These are games that have been launched in, let's say, the last year or more, and these scores were obtained with a Radeon RX 6800 XT running on 1440p resolution. The FPS values we can see range from 67 to 95. And with this, we've covered quite a lot of slides, so I believe we're going to take a short break and look at some of the questions that you guys have. All right, we see quite a bit of questions, a lot of callouts again. So there's one question from Abhishek Prusti, who's asking, after Vega 64, how hard was it for AMD to have something revolutionary like they have in the CPU space? So with these things such as GPU architecture and CPU architecture, these are in the works or rather in the planning stages and actually being developed in labs for roughly 5 to 10 years. So Vega 64 isn't that long back, which is why even when Vega 64 was announced and launched, you still had a lot of work around the RDNA 2 and the RDNA 1 cards being done in the back end. It's just that they weren't ready, and AMD usually doesn't comment on product launches that are in the works. So this thing has been in the works for close to 10 years, you could say. That's usually the industry practice. We don't know exactly what AMD ended up spending in terms of time as well as investment. And 10 years is quite a lot of time, especially to work with their partners in the hardware space as well as in the video game industry to figure out exactly what are the demands and how can AMD meet those particular demands. So I wouldn't call it, I don't call it as being hard. It's just that it was something that was inevitable and going to happen anyways. Then we have another question from Abhishek Prusti, who asks, even if the world is moving to open source tools for graphics, hardware is making a how hard is it to make a technology equivalent and have it ready for the new launch like fidelity effects, super resolution and ray tracing? So we've already touched upon ray tracing. So that's something that has been around for a couple of decades, and the thing was, graphics cards would be really stressed in order to get hardware accelerated ray tracing done in video games. They were being used for rendering in, let's say, the content creation space. Folks using Blender, 3ds Max, Maya and all those things, they're already using graphics cards to render lifelike textures. It's just that doing that real time took up a lot more compute power, and that's why you saw this massive time being taken by all hardware developers to push their ray tracing solutions. And again, it's a combination of waiting for let's say the right APIs and tools to be present. It's then involves waiting for foundry partners to come up with transistors that are power efficient and small, and then there's also R&D taking place with hardware manufacturers like AMD. So again, it's something inevitable. It's just that it takes quite a lot of time. Then okay, last time you crashed YouTube. That's Rohit 12525. I don't believe I did that, but again, I could be a contributor. Then there's another question from Ranjit, who's asking, how much beneficial is the RX 6000 series for gaming? Will it run the most recently released AAA games such as GTA 6 and Cyberpunk when they'll be available in PC? So GTA 6, yeah, we don't even know if that's coming out anytime soon, since but they're still pushing out GTA 5 on practically every other console and system, whereas Cyberpunk has already been out, but then again, it's just been out for like barely 10 days, so they still have a lot of optimization to be done, and I believe performance on PC is very good. Consoles, honestly, not so well, but over time, as CD Projekt Red works on all the performance patches, and day 1 patch is already out. I believe we were on version 1.04 last I checked, and give it about a month or two and you should get good performance. But again, if you wish to play it on day 1, then it's sad, but we have to expect performance glitches. It's a give and take. Game developers honestly don't get enough time to push out their video games. Okay, Abhishek, I have answered your questions. Then we have one question from Vidhu Sarwal. How does the RX 6000 series perform for machine learning? So with machine learning and anything to do with AI, you have to really pick the right API and framework, one. And because RDNA 2 has only been around for barely 20 days or so, you should see researchers and software developers start to work on the new architecture and optimize their frameworks and libraries. So over the course of the next 3 to 6 months, you should see releases from all major AI and ML frameworks trying to sort of incorporate, let's say, the best features of the 6000 series. Usually, if you pick up anything that has GPU computing, so that's like OpenCL or OpenGL, they will work fine, but it's always best to work with the APIs and the frameworks that the hardware vendor provides from their end, because there's also a lot of optimizations on their end which could really help. But then again, you could use any of the open source technologies and get pretty decent performance. We have not personally tested any of the AI ML libraries because this is primarily a gaming card, but we can certainly go down that road. Then we have a question from Rahul Malviya, who's commenting about, it's rather a comment, why is there a high price in the market than the launch price in India? Again, there's a lot of factors over there. There are taxes as well as individual tiers in the distribution chain, which all contributed towards high prices, and usually these normalize over time. So I believe the Ryzen 5000 series had similar problems at the very beginning and they leveled off later on, and we should see the same with the the Radeon RX 6000 series as well. And I believe that's 4 or 5 questions, so we'll move back to the presentation. And where is that? Here we go. Now, last we were looking at the ray tracing performance in 1440p for the Radeon RX 6800 XT. And next up, we'll be looking at another use for hardware accelerated ray tracing, and that's for content creators. Now, content creation as well as media authoring applications make use of ray tracing that's present in GPUs. These might be enterprise GPUs or even normal consumer GPUs like the Radeon RX 6000 series. Applications such as Blender, Houdini, and Autodesk Maya, they all use hardware accelerated ray tracing to produce lifelike 3D renders. Here we see the performance uplift across several popular benchmarks for Blender 2.9, while comparing the 6800 XT with the previous gen Radeon 7. Now these benchmarks used the Radeon Pro Render plugin for Blender, which allows the software to make better use of ray accelerators present in the GPU. Now we can see a performance uplift ranging from 49 to 68%. Again, Blender can use the GPU as is, but if you use Pro Render, which is something that AMD provides, you can get a little more performance. This is touching upon the AI ML question that we saw previously. Moving on, we are now looking at video editing applications. DaVinci Resolve and Adobe Premiere Pro are two of the most popular video editing applications, and the RX 6900 XT is seen to have up to 3 times the performance of the Radeon 7. It should be noted that the workload comprised of 4K footage running at 60 or rather 59.94 FPS and had a lot of visual effects laid onto it. Now, exports are primarily CPU bound when you're looking at these video editing applications, but when you lay on a lot of GPU effects, those things are then offloaded to the GPU for processing and they become GPU bound. So that's where GPU helps with video editing applications. And in DaVinci Resolve, we see up to 1.7 times the performance. Moving on, we have 4K gaming benchmarks on the 6900 XT. You'll see 2 graphs here. One that's lightly colored, that's on the left, and one that's dark red or rather red, which is on the right. The lightly colored one indicates FPS values in games as is, whereas the dark red or rather red shows FPS values with the smart access memory turned on. We'll be looking at smart access memory shortly. Coming back to the FPS values, we see, let's say, more than 60 FPS across all the games, and even more when you factor in a smart memory access or smart access memory. I tend to confuse the two. Now, these games have been around for quite a lot of time. I would say around 1.5 to 2 years. And the slide that we're looking at right now are more recently released games. These were released in the last 2 months. Here we see Assassin's Creed Valhalla, Dirt 5, Godfall, and Riftbreaker. So it goes on to show that the Radeon RX 6000 series of graphics cards are good even for the most recently released titles. Now obviously, over time, you should see performance patches from the developers and even driver updates from AMD bringing up the performance in these titles even more. Then we are going to see ray tracing performance. So previously we saw the ray tracing performance of the RX 6800 XT, and now we are looking at 6900 XT's ray tracing performance. All these games have been run on 1440p resolution with smart access memory enabled. We see FPS values ranging from 91 and going all the way to 139. The games featured here include recently released titles as well as games that have been around for a while. Now, next up, we have seen that, let's say, the RX 6000 series of graphics cards, they were all released with 16 GB of video buffer. And that can seem to be overkill at first glance, but when you check the memory usage across several titles, all of them running at 4K resolution, you do see high memory usage. Now, among the games in front of us, we have titles such as Red Dead Redemption 2, which was released in 2018 and features large open vistas that do consume a lot of video memory. In this case, it's about 13.6 GB. And as we look towards titles that were released in 2019 and 2020, we see even more games consuming high video memory in 4K. Now, with that, we have covered even more, and I think we should take a short break to answer a bit more questions. Again, we should mention that the 10 best questions that are asked during this particular AMA, we're going to give out Amazon gift vouchers. So please send in your questions in the chat. Again, where were we previously? We handled Abhishek's question. Okay. Then, okay, all right. How much beneficial is RDNA 2 and the RX 5600 series for coding and video editing? So Ranjit, so RDNA 2 is the RX 6000 series and RDNA 1 is the RX 5000 series. So I believe you're just asking about both series for coding and video editing. Now with video editing, we saw the performance in let's say DaVinci Resolve and Premiere Pro, and we saw them to be quite beneficial. Let me just bring up those slides. Where are they? There you go. So in Premiere Pro, we saw an uplift of up to 3x, and in DaVinci Resolve, we saw 1.7 times the performance uplift. This is between the 6900 XT and the previous gen Radeon 7. So Radeon 7 is before the RX 5000 series. So in video editing, especially if you have a lot of GPU effects laid on to your timeline, you're going to see quite a lot of performance improvement because those workloads are sort of pushed onto the GPU. Whereas if you don't make use of a lot of GPU bound effects, then it's primarily going to be CPU bound, and the amount of cores that you have is going to help. So if you were to have something like a Ryzen 9 5900X or a 5950X, one happens to have 12 cores, the other is 16, and both of them have multi-threading, so you can get 24 threads or 32 threads, then you'll see a lot of performance uplift compared to what you're running right now. And because the Ryzen 5000 series tend to be, or rather are, much more performant compared to the Ryzen 3000 series that was launched last year, there's gains over there as well. So if you factor the two together, that is putting the Ryzen 5000 series along with the Radeon RX 6000 series, you're going to get even more performance in the long run. Coming back to questions. Someone is excited, Ranjit, so are we. When are budget cards launching? This is a question by Sahibjeet Singh Bains. So we have no idea as to the exact timeline because AMD has not revealed the timeline of the budget cards, but going by history, we've seen these things come out within 6 months of the high-end launch. Sometimes it varies. AMD launches the mid-range cards first and then moves into high-end, and sometimes like this time we've seen the high-end being launched first. So probably in the next 6 months you should see mid-range cards come out, but then again there are a lot more factors. There's also supply things that need to be sorted out, so there's no concrete way of saying exactly when it should come out, but 6 months is the estimate that you're going to go with. Then there's a question by Krish Yadav who was asking, how can I afford a 6900 XT? Best question. Okay, so the 6900 XT costs about 94,338 or 668, which compared to the competition is pretty good in terms of value for money. So the kind of performance that you're getting with the 6900 XT, it's very difficult to match that if you're going with any other card. And at that particular benchmark, it's a very good card to have. You might want to check out a review where we explored the pricing and value for money of these cards, and I believe we are painting it in a pretty good light considering the kind of performance you can get with the 6900 XT. Again, you really have to pay money in order to get the very best, and that's always been the fact with the high-end segment of any hardware. And there's a little bit of cross communication happening. There's Atmadeep Mishra who asks, will it contain hardware solution for ray tracing or a hybrid one as AMD says in development? So the ray tracing solution is already out. It's called DXR. It's Microsoft's API for ray tracing, and all the Radeon RX 6000 series make use of DXR. They are made possible thanks to something called a ray accelerator. We've seen that in the slides previously, and each compute unit within the GPU has these things. So depending on which card you get, the 6800, 6800 XT or the 6900 XT, you'll get different levels of ray tracing performance. Again, I can bring up the slide for that. Just a sec. There you go. So this is the ray tracing performance of the 6900 XT. This is with AMD Smart Access Memory enabled. And if you're looking at the 6800 XT, we should have it over here. There you go. So with both cards, you're getting more than 60 FPS in recently released titles. So if ray tracing is something that you're really gunning for, then these cards are pretty good at it. Coming back to one more question before we continue. Ajay Kumar Sahu asks, can we connect an AMD RDNA card with a laptop? So there are external enclosures for graphics cards which allow you to run desktop grade graphics cards with what you call laptops. But then again, that depends on the enclosure, because the enclosure is supposed to provide a certain amount of power. And there's also the fact that larger cards such as the 6900 XT and the 6800 XT, the dimensions should support whatever enclosure you're picking. So as long as those things are factored in and you can sort of check the enclosure's website, they should also mention all the cards that are supported by the enclosure. You should be good to go. But we don't see any reason why it shouldn't be supported. All right. Now we will go back into the slides. So I believe we were somewhere around here, and we were looking at the VRAM that these cards feature, which is about 16 GB, whether video games actually make use of it. And what we saw was games that were launched starting in 2018, even going all the way into 2020, they all consume not all, they do consume quite a lot. And the recently released Godfall video game tends to consume around 15.7 GB of video buffer when running at 4K. So there's some, something to look forward to. And this is with ray tracing on. So ray tracing coupled with 4K resolution, they do consume quite a lot of memory. Moving on. It's not just pure FPS crunching that graphics cards do. The overall gaming experience is also enhanced by use of several APIs and features. Now we have several of those highlighted here. There's FreeSync, which matches your monitor's refresh rate to the FPS that you get in games. What this does is it prevents something called screen tearing. So screen tearing is usually seen when you see half the screen at let's say cutting off, or some glitch that shows state objects being sort of spliced. So that's how you notice screen tearing. And then there's HDMI 2.1 VRR, that's variable refresh rate, which enables large format displays such as TVs to sync their refresh rates with the FPS values obtained in games. Then there are performance presets which can be applied on the fly to get a little extra boost in video games. And then we have two more prominent features, that is Radeon Anti-Lag and Radeon Boost. We're going to go into a little more detail with those in the next slide. Now, anti-lag reduces input lag in GPU-bound games so that games appear a bit more responsive. This helps a lot in esports titles where quick reaction time can mean the difference between first and second positions or life and death. Then there's Radeon Boost, which dynamically alters game resolution to increase frame rate when there is fast movement. So it will optimize for higher resolution and good quality, or rather high fidelity, when you're looking at let's say not much movement happening on the screen, but let's say there's an event or action happening, maybe an enemy sort of jumped in and you turn rapidly in order to view the enemy. That rapid motion, when the fidelity is like really high, that can drive your frame rate down. But with Radeon Boost, that frame rate is not altered, or rather the GPU tries to catch up and retain the frame rate at a higher level so that your experience is much better. Again, this also helps with esports titles because we tend to see a lot more rapid movement in esports. Now, those were features. Now, this is more about overclocking. Now, overclocking used to be the domain of enthusiasts, but with improvements in the Radeon software, anybody can go for or rather get a performance boost depending on which of these presets they are looking at. There's Rage Mode, which is a single toggle within the 6800 XT as well as the 6900 XT that gives you instant performance boost. The software basically tries to overclock on its own and tries to figure out exactly how much more performance you can get depending upon one, your hardware, as well as the kind of cooling that you have in place. Then you have performance tuning via the automatic overclocking method. Now that gives you a simple what do you call voltage frequency curve that you can adjust. Your TGP as well as fan speeds will be sort of set, but the VF frequency, when you alter that, you can get a little more performance. Again, you might have to play around with different levels in order to see what is better for you. And lastly, for enthusiasts who want absolutely complete control over the entire process, you have the manual performance tuning presets, not presets rather. It gives you access to all the features that are present and that can be accessed and varied by you. So if you really know what you're looking for and what all settings you need to play with, then manual is where you want to go. Then you have smart access memory. We've touched upon this several times in the previous slides where we had two different graphs right next to each other for certain titles. Now, smart access memory is something based on a PCIe 4.0 spec called resize bar. It basically allows your CPU, that is the AMD Ryzen 5000 series, to gain access to the entire GPU memory. So the CPU not only has access to the RAM that is connected to the CPU, but also the entire 16 GB of video buffer that's present in the GPU. Now this removes bottlenecks which might have otherwise been present and gives you a little more performance. Again, video game developers can factor this in while developing the video games to get a little more performance, but as is with these things not factored in, just switching them on, we do see performance gains already. And this requires that you sort of upgrade your BIOS and switch on two toggles within the BIOS settings. Once you do that, you can get an average of around 6% more performance in games, and it can go all the way up to 11% as well. Now these graphs that you see in front of you are with the Radeon RX 6800 XT. The dark red part is with smart access memory switched off, and you get a little extra performance boost at the top. That's with SAM on. Now this is for the 6800 XT. We can also look at the 6900 XT. These benchmarks are all either run on 4K, that's on the left, and 1440p on the right. You can see varying levels of performance at different resolutions. Again, this is with no input or rather no modifications made by the developers. These are games that are running as is, and again you see quite a significant performance increment across all of these games. Again, it varies depending on the resolution that you're playing and the kind of hardware that you have. So right now, in order to make use of smart access memory, you need a Ryzen 5000 series CPU, the right motherboard, which is a B550 or an X570, the right BIOS, which you'll find on the motherboard vendor's support page, and Radeon RX 6000 series GPU. And with that, we end up on the last slide. We are going to summarize all the GPU specs over here in case you guys were wondering, and we'll head back to the questions for the last round. Again, we have Amazon gift vouchers for the top 10 best questions asked during the AMA session. So please send in your questions. I believe we had answered Atmadeep Mishra's question last. Then let's take a look at more. Wow, there's quite a lot of questions. Can't even get my bearing. how are the temperatures while using it in graphics intensive games? This is by Able Star. Now, idle conditions we've seen around 42 to 45-ish degrees, but with games running we've seen as high as 80 to 81 degrees Celsius. This is with an open test bench, so those are kind of normal temperatures that we've seen in high-end cards, so nothing out of the ordinary. MTB Rider Vunch asks, are there any overheating issues of the 6800 XT? Again, we tested the card on an open bench, so our temperature levels are all normal for all high-end cards that we've experienced so far, so nothing out of the ordinary. Then we have Sriram Sen asking, why are APUs not launched using the RDNA 2 microarchitecture? So Sriram is basically asking, why aren't there APUs which use the Ryzen cores along with RDNA GPUs? Again, that's something that AMD can comment on. We have no clue about. They have not let us know anything. But usually when you see CPUs come out, there's usually again around 6 month-ish gap before the APUs tend to arrive. That is if the APUs are planned. We have no idea if they are, but usually you will end up seeing them because there's plenty of demand in that particular segment. So Sriram, I would say you should wait for a while and you will end up seeing APUs, hopefully. Then we have Lion Gerd Gaming ask, can we reach 100 FPS on GTA 5? As in on 1080 as well as 1440p very easily. On 4K gaming as well, yeah, you can cross 100 FPS on GTA 5 because GTA 5 has been around for quite a long time, which is why practically any graphics card coming out can get really good frame rates. Again, this is depending on what kind of features that you have turned on. We are assuming that you're not going to have proprietary APIs switched on because proprietary APIs tend to screw with performance a lot. Then we have Naveen Kumar who's asking, is AMD planning to have something to compete with DLSS 2.0 down the pipeline? Can we buy the 6000 series on the promise to get it through driver updates or something? Again, this is a feature question that is in the works apparently, and we can't comment on exactly when it's about to come out or if it's actually going to come out. This is something that only AMD official spokesperson can comment on. Then we have a question from MTB Rider One who's asking how to use the full cache memory in the 6800 XT. Now, I believe that could be answered with the whole smart access memory slide. So if you have the right CPU, the right GPU and the right BIOS along with the right motherboard, you can turn on something called smart access memory, which requires two toggles in the BIOS. One is resize bar and the second is above 4G decoding. If you do that, then the CPU can access the entirety of the video buffer or the cache in whichever Radeon 6000 series GPU you have connected. Then we have Vaishali Bakkar who's asking, could we do heavy gaming as well as editing on the RX 6000 series GPU? Yes, Vaishali, you can. We actually did put up a slide. Let me bring it up. This would be the second time. There you go. This is for video editing that is performed using the Radeon GPU. Then we have again heavy gaming. That's another question that you asked. Heavy gaming, these are all high-end cards, so heavy gaming should be handled quite easily. We've seen frame rates more than 60 FPS across several of the titles that we showed today. Pranav Sharma asks, is it best for editing? It is really good at editing, which is something we saw, and we currently have that slide in front of you. There's a 3x performance uplift over the Radeon 7. That's quite significant, so it is really good for editing. But then again, it depends on whether you have a lot of GPU bound effects on your timeline. We have another question about DLSS. Then we have something about stocks. With the Ryzen 5000 series, we believe stocks should level off in a couple of months. These cards have just been launched, so there's usually a little bit of time where you find market demand and stock sort of not tying in, and that should usually resolve in a couple of months. We have another question about editing and gaming. Again, the slide is right in front of you. You can see an uplift of 3x. It's another question about PUBG. Can we reach 100 FPS? In 1080 and 1440p, you can easily reach 100 FPS on any of these cards. Then we have My School. No, that's a person called My School who's asking, can it handle 4K gaming for 10 hours? Now, if you have really good cooling within your chassis, it shouldn't really matter how long you're gaming. We've personally been, as in most of the guys on the Digit team have personally been guilty for gaming for roughly 15 to 16 hours in one day. So 10 hours shouldn't be a problem. And 4K gaming, it's going to be quite intensive, but if you have really good cooling, again, it shouldn't be a problem. But from health perspective, try to keep your gaming in check, especially if that's like 10 hours. Then Liongird Gaming asks, can we make animation video on this? Yes, you can use any of the popular animation software as well as 3D modeling software, which I believe is on this particular slide. Again, we saw significant performance uplifts across popular benchmarks in Blender. So if Blender is something that you're interested in, then yes, the RX 6000 series is pretty good. Then, which processor is best for this? This is a question asked by Srikumar11D. Now, there's something called Smart Access Memory, which really comes into play if you have the compatible processor. That is, the Ryzen 5000 series is definitely compatible along with the right motherboard and the right BIOS with the RX 6000, and you'll get slightly better performance when they're paired together. Then we have MTB Rider Vansh asking about RDNA 2 difference over RDNA 1. Well, practically any slide that we've shown today will showcase that. You can just go through the entire video at any point and get your answer. Then we have price of 16 GB VRAM. Actually, all three cards, this is by HS Gaming Point, all the three cards, that is the 6800, 6800 XT and the 6900 XT, they all have 16 GB of VRAM. So if you're going for the 6800, then the price with taxes is around 54K. Then for the 6800 XT, it's around 76.5K. And lastly, for the 6900 XT, the price is around 94.5K. How's ray tracing? Okay, I'll bring up the slide for that. Give me a sec. Ray tracing performance. There you go. With the 6900 XT running on 1440p in DXR games. What is your opinion? Now, this is a question by Rishu S, who's asking, what is your opinion? How much is it future proof? So, any game that's coming out in the next year could end up taxing any high-end card. The fact is, most people for the next 3 to 7 years can make do with a high-end GPU. All you need to do is try to understand different settings within the graphics settings panel that you can alter, and you can get good frame rates without dropping visual fidelity much. Obviously, after a while, there will be a massive generational difference and your cards will end up, getting poor performance, but that's roughly 3 to 7 years down the line. So that's how much you could consider the life of any GPU, not just high end, even mid range. It really depends on what kind of settings that you're comfortable and you enjoy playing at. Then we have HS Gaming Point asking about the price. Same goes for CRX Yamraj. Okay, so the 6800 is around 54,000. The 6800 XT is around 76.5 thousand, and the 6900 XT is at 94.5 thousand. Then we have Sky asking about budget GPUs. Again, there's no indication from AMD about budget GPUs launch window, but we've usually seen them come out around 6 months after the high-end ones, or the other way around. 6 months is usually the gap for the entire lineup to be, launched. Then we have Rohit12525 again asking us a question about power supply that should be used to support both the motherboard and the GPU. For power requirements, I can bring up the last slide, I believe. So you can see the total board power, which is the second last metric. So the 6800 consumes around 250 watts at peak. Same goes for no, or rather it doesn't. 6800 XT and the 6900 XT both consume around 300 watts at peak. So that's your GPU. Then you have the CPU. Depending on whichever you get, it could go, let's say, from 19 to 60 watts, going all the way to 250 to 300 watts. We've seen that much being consumed by CPUs alone as well. Again, all of this is at peak load. Motherboard usually doesn't consume a lot of power, so you can put out around 15 to 50 watts for that, depending on what all features you have. PCI Gen 4 consumes a bit more power, and then the amount of USB ports that you have connected, as well as the amount of cooling fans that you've connected, all of these contribute to power consumption by the motherboard. Once you factor all of that, you can get, let's say, around 750 to 800 watts is what you should sort of aim for when you're getting a power supply. But this is highly variable, and what you should do is go to any power supply vendor's website. They'll have something to calculate your overall power consumption of the entire system. Use that particular tool to calculate exactly how much you're going to end up consuming, and then go for an appropriate power supply. That would be the best course of action. Then we have Faraz asking, can you run test games on both rigs to prove the performance? Well, Faraz, you can check out a review on our website. We have reviewed all three cards, that is the 6800, 6800 XT and the 6900 XT, to get a good idea of the performance across the stack of cards that we've tested. Then, will there be a budget RDNA 2 card? We have answered this. We have no idea, but 6 months is usually the time. Then, does it have any AI-like feature which improves the graphics without harming the FPS, or is it in a developing state? Again, this is a question around DLSS, which is a competition feature. We've answered this. Right now, we don't have a time frame on whether such a feature is in the works or when it's coming out. I guess you'll have to wait and watch like the rest of us. Then there's Khwaja Ahmed asking, can we see AMD in smartphones? That's the space that only AMD can comment about. So far in smartphones, we've seen ARM architectures, not much from x86, and AMD CPUs currently, or other general purpose processors, are usually using x86. So we really can't tell. It's up to AMD to figure out whether they want to get into the smartphone business. Then there's another question about budget GPUs. Again, 6 months probably. What's the price? We've again mentioned this. 6800 is around 54 grand. 6800 XT is 76.5 and the 6900 XT is 94.5 grand. Budget card range by Abhishek. Again, Abhishek, we don't know, but you could wait around 6 months. MR Compressor is asking, why do some graphics cards contain a heatsink and some contain a heatsink and fan both? Now, this is to do with the TDP, or the thermal design power. Whenever a GPU is being designed, the engineers sort of look at the amount of heat that is dissipated by the GPU, or the heat that is produced. And in order to keep that GPU functioning at a certain level of performance, you need to pull that heat out and dissipate it. That's the function of the heatsink. Now, low-end GPUs or low-power GPUs don't produce a lot of heat, so you will see just a heatsink that is present in the absolute entry-level GPUs. But as you move into the higher entry level as well as mid-range, and there's no question about high-end, you will see active cooling with not just normal heat sinks or aluminum blocks. You'll see exotic materials being used. You'll see vapor chambers, heat pipes, multiple fans, and modification of the shroud to focus airflow in a more optimal manner. All of this depends on the amount of heat that is generated by the GPU, and this is a function that is performed either by the engineers as well as the AIB partners who make cards later on. If RDNA 2 is more, so this is a question by Amitosh Kumar, who asks, if RDNA 2 is more efficient than previous generation, why is it recommended to use higher rated power supply? Well, these are high-end GPUs, which is why you need more power. It's not exactly a question of power efficiency, and because it's more power efficient, within the same thermal envelope, you're getting more performance. So there are two approaches that a GPU manufacturer can take with power efficiency. One, it can either reduce power consumption and give you normal performance, or it can increase power consumption to high-end levels, which is around 250 to 300 watts, and give you really good performance. Now, it really depends on what you are after. High-end cards tend to go with the latter approach, that is, give you more performance and consume more power. Mid-range and lower-end cards, they tend to consume less power and give you, a moderate amount of performance. So it really depends on what kind of performance range that you are looking for. It varies. Then we have a question from CRX Yamraj asking about budget CPUs. This is pertinent to the Ryzen 5000 series. Again, it's quite similar to GPUs. Once you have one end of the segment or one end of the spectrum come out, then it takes roughly 6 months before the entire range is launched. Then you have, does it have any AI-like features improving graphics? Again, this is about DLSS, which we've already answered. Then we have SolveTube asking, will any new budget CPUs arrive under 20K? Again, you'll have to wait and watch. It's usually 6 months before we get to know what's coming out and what price range it will be out for. And it seems that quite a lot of the questions are what we've already answered. There's Arjun Singh who's asking, which PCI Express version does it come with? These are all compatible with PCI Gen 4.0, but the bandwidth is usually not that much as in for the actual workloads. So you can run it on PCI Gen 3 boards as well as Gen 4 boards. You won't see much of a performance differential. And is the AMD GPU good for streaming? Well, this particular live stream is running off a 5900X and a 6900 XT, and I believe the quality of the stream should be pretty good. It's 1080p, so but then again, I'm not running a video game at the same time, but we have done it with the 5900 XT, and we got pretty good performance, as in there were no frame drops, and in OBS, which is the software that we tend to use, we didn't see drastic reduction in quality. Not even drastic, even minor reduction in quality was not experienced. So they are good for live streaming. And with that, I believe we are at 8 o'clock, which is 1 hour since the stream began. Again, the 10 best questions that were asked during the AMA or are in the chat section. We are giving out Amazon gift vouchers for the 10 best questions. So I believe you have 1 more minute for asking your question. Again, thank you for joining in and being on this particular AMA. We looked at the AMD RDNA 2 based Radeon RX 6000 GPUs. We've also done the Ryzen 5000 series CPUs as an AMA, similar format. You can check it out in our YouTube history. And that's about it for us. Thank you for joining in, and hopefully we'll have more AMAs in the future. Again, fair declaration, this AMA was sponsored by AMD, and all the performance metrics, including all the graphs and values that were shown, was shared by AMD. If you wish to see more information, we have reviewed all these cards, including the CPUs, the Ryzen 5000 series CPUs, on our website. Please do go and check them out. And thank you for watching, and I hope you have a good night.